In this video, we're going to approximate the area bound under cosine x on the interval from minus pi halves to pi halves. So we're asked to consider that function over that interval and approximate the area bound by the curve in the x-axis using first a lower sum with n equals 4 and an upper sum with n equals 4. I'm also going to be using rectangles of equal width, which is not necessarily specified here, but was my intent when I wrote this problem down. So I'm going to start by graphing cosine over this interval. Going on and including some nice points there, which will be important for us. Let's see, over this interval we just have a cosine graph that starts at 0 and then works its way down to 1. It does the same thing on this side. Cosine's, of course, a nice, happy, even function. Let's see if I can make that look a little nicer, though. All right, not to scale. But that region under the cosine graph, that's the area we're trying to approximate with a lower sum with n equals 4 and then an upper sum with n equals 4. Well, let's just think about that. If I did want to use rectangles of equal width, then I know the width of each rectangle. B minus a over n, of course, so pi halves minus a minus pi halves all over n is 4. So let's see, that's pi halves plus pi halves is pi over 4. And so I already have tick marks in the correct spots, and I can see I have 1, 2, 3, 4 little subintervals in my partition on which I can create rectangles. So to start off with a lower sum, on this side of the cosine graph, I have a function that's increasing, so that value on the left-hand side will be the minimum. On the other side, the function is now decreasing, so it's at right-hand endpoint. So here we have a case where the lower sum, not always using a right or left-hand endpoint, that it changes because the function is sometimes increasing and sometimes decreasing. Well, let's build a little table of values that'll help us out through the whole problem, but I think I can find the areas of these rectangles pretty easily. Cosine of pi halves and minus pi halves is 0. At pi fourths and minus pi fourths, we have that root 2 over 2. And at 0, we have 1. Well, what I see in this diagram are two rectangles with no height, because the minimum value on their respective intervals is actually 0. And then I have two rectangles that actually have a height of root 2 over 2. And so here in part A, 0 plus root 2 over 2 plus root 2 over 2 plus 0 times the width of each rectangle. Let's see, that'll give me root 2 pi over 4, which is in itself that lower sum, but let's get a decimal approximation. Root 2 times pi over 4 is about 1.11. So there is my lower sum estimate. Now let's see if I can think about an upper sum. So now on each interval I'm supposed to take the max. So much larger rectangle here. And here I get some green rectangles that go all the way down. All right, so I'm going to get a much larger figure here, which I should. It's an upper sum versus a lower sum. So now this green rectangle has a height of root 2 over 2 there at x equals minus pi fourths. And I have two rectangles in the middle. They both have a height of 1. Where I go up and touch, and I get those two rectangles there. And then times pi over 4. So let's see, 2 plus root 2 times pi over 4. And I'll get a decimal approximation of that. And that comes out to about 2.68. So now I know the true area under this cosine graph is somewhere between 1.1 and 2.68. I have an upper sum and a lower sum.